Good afternoon, Algebra 2. Today we're talking about quotients with radicals, which only makes sense because yesterday we did, or a couple days ago rather, we did products with radicals. So remember, products was multiplication, so therefore quotients is going to be division here. Alrighty, and this slide you do not need to write down, however, we do need to talk about it. So it says the expression 3 over radical 2 is considered by many people to be unsimplified because there is a radical in the denominator. This is not allowed to happen. There's a historical reason for this. Before calculators were available, to estimate an expression like 3 divided by radical 2 meant having to do long division, you guys remember this from forever ago, with a divisor that is the infinite decimal 1.414213562. There is no way to do this division and be certain of the accuracy of the result. So people found an equal number without a radical in its denominator. Example 1 shows how this can be done. Okay, so example 1 says to rewrite 3 over the radical 2 without the radical in the denominator. Okay, so this is what they used to do way back when, and it's called actually rationalizing the denominator. So rationalizing the denominator. Okay, and there's a process for this, and the first step is to identify where your radical is, which is right here, the radical 2, and what you're going to do is you're going to multiply this fraction with another fraction that's going to get rid of this radical 2 here. And I promise that these will get easier. It's weird to do the first one, but this will be just like riding a bike to you here in a bit. So what we do is we say, all right, well, to get rid of that radical 2, I'm going to multiply by a radical 2. And you'll see why I did that here in a second. So if I do radical 2 on the bottom, I have to do radical 2 on the top to keep it balanced. It's just like an equation where what you do on the left, you got to do on the right, and vice versa. In a fraction, what you do on the bottom, you got to do on the top to keep it even. And the reason that this works is essentially because radical 2 divided by radical 2, well, those would both cancel and be 1. So essentially, we're just multiplying by 1, which we know doesn't do anything. So this is why we're allowed to do this, okay? So essentially, it's going to be the same radical every single time. If this is 2, this is 2. And then we just have to figure out what that is. So 3 times the square root of 2. I cannot actually perform that multiplication because 2 is under the radical and 3 is not. So 3 has to stay outside and 2 has to go underneath. Downstairs, though, they're both under a radical. So what I can do is put them under the same radical. So we have the square root of 2 times 2, and then we can actually perform that multiplication. So we have 3 square roots of 2 on top. Downstairs, we have the square root of, well, square root of 2 times 2 is 4 underneath the radical. And then, if you notice, we can actually take the square root of this number. That's the whole idea, to get rid of that radical in the bottom. So we keep the top the same. So 3 square root of 2 over, well, what is the square root of 4? Voila, it's 2. And it's not actually a coincidence that this ends up being what we started with without a radical. That actually should happen there. So this is our answer because all they wanted us to do was get rid of the radical down in the denominator, which we did. It's gone. We are allowed to have them in the numerator, just not downstairs. Okay? So this guy is equivalent to this guy, what we started with. And if you don't believe me, let's grab our calculators and do them both. So I'm going to do this one first. So 3 divided by the square root of 2. So 3 divided by the square root of 2. And that's going to give me some decimal. And all I'm looking for is this decimal to be the same darn thing. So I'm going to do 3 times the square root of 2 here. So 3 square root of 2. So that's my whole numerator here. And then I'm going to divide it by 2 because I still have that part of my fraction here. Is that the same decimal as what we had the first time? Yeah, it is. So essentially 3 over radical 2 is the exact same thing as 3 square root of 2 all over 2. So these are actually equivalent fractions here. The only difference is this one is written properly and this one is not. We had to rationalize a denominator to get it out. Alrighty, this slide just kind of tells you what rationalizing the denominator is. It's the exact same process we just did, but here's your definition. It's the process of writing a fraction in an equivalent form without irrational numbers in the denominator. Okay, so nowadays we rationalize denominators to recognize equivalent expressions. Obviously we don't really do long division anymore, but we want to be able to say, hey, I recognize that number, and trust me, if you're planning on going to pre-calc, you are going to be happy you know how to rationalize denominators. Okay, so if that's you, you're definitely going to want to pay very close attention to this. Next thing we need to talk about is what is called your conjugate. And we kind of talked about these back in imaginary numbers. When they were imaginary numbers, they looked like this, a plus bi. Now its conjugate would have been a minus bi. Okay, so kind of the same idea here, except we have, instead of bi, we have radical b. So if I have a plus radical b, then it's a minus radical b. Or I could change the sign on a and keep b the same. So the third one we never really talked about here would have been negative a plus bi. Okay, that was one too, we just never really used it. So either one of these would be a conjugate of this first thing here. Remember, it's just changing one sign on one of these terms. Example 2 says, suppose a is greater than 0. Rationalize the denominator of 1 over the square root of 7a. So this is done the exact same way as we did the first problem. So how do I get rid of it? Well, I'm going to multiply by the fraction, and I'm going to take this exact same radical. Never mind that there's a 7 and an a in here. We can do them both at the same time. So I'm going to say, all right, times the square root of 7a on the bottom. And I also have to put a square root of 7a on the top to keep it balanced. All right. This would be 1 times the square root of 7a. So we'd have 1 square root of 7a. We don't really need to write the 1 there. So I might drop it in the next step here. Now downstairs, we would have two things, and we could put them underneath the same square root. Instead of writing 7a times 7a, I'm actually just going to do it. So we first do 7 times 7, which is 49. And then a times a, which is a squared. Sorry, that's a 9. And then we're done with that. So we did our a's here too. So we're good. Now we can't leave this square root, so we actually have to simplify. So 1 times the square root of 7a is just the square root of 7a. All over. Now again, if I wanted to, I could break these apart. We have the square root of 49 times the square root of a squared. Well, what happens there? We keep our top, 7a on top. Downstairs, square root of 49, we know that one, that's 7. Square root of a squared, squares and square roots cancel each other, so I'm just left with a, so I have 7a downstairs. So it's a little weird, because we have the square root of 7a over a regular 7a. But the reason that this is just 7a up top is just because we had a simple 1 up there, so it didn't really change anything here. All right, we are done rationalizing the denominator because guess what? We have no more square roots downstairs. Okay. Example 3, suppose x is bigger than 0. Rationalize the denominator. Huh, that must be what we'll be doing this whole time. So we have the square root of 9x cubed on the bottom. So we need to multiply by that whole thing again. So we have square root of 9x cubed on top, square root of 9x cubed on the bottom. Okay, it's always that way. Whatever you put upstairs is downstairs. Same thing here. So we have 6 times the square root of 9x cubed. The 6 is not underneath, so I have to keep it outside. So 6 square root of 9x cubed. Downstairs, though, I can put these together. And we're going to do it one step at a time again. So 9 times 9 is 81. And x cubed times x cubed is x to the 6th power. Remember, we multiply bases, we add exponents. Yay! Okay, we're not done though. Keep simplifying. We have 6 times the square root of 9x cubed. 6 times the square root of 9x cubed. Over, well, we can break these apart now. You know that they're going to be the square root of 81 and the square root of x to the 6th. So square root of 81 is 9. Okay. And then the square root of x to the 6th power. Okay. So that would be like x to the 6th. And then we take the square root or the 1/2 power. So half of 6 is x to the 3rd. So x to the 3rd goes downstairs. Notice, this is not a coincidence. We keep ending up with whatever was under the square root here. That will happen for you every single time on the bottom. Okay? On the top is going to be different every time. All Alrighty, now we're actually not done here because I know I can't take the square root of x cubed, but could I break that down? Remembering back from a couple lessons ago, could I break this apart into something I can take the square root of? And remember, this is a little 2 here. Can I take the square root of 9? Absolutely. So let's just keep the 6 hanging out front. Square root of 9 we know we can do, and that's going to be 3. And then I'm going to rewrite the x's again, but I'm going to break them down into x squared times x to the first, because I can take the square root of x squared. This guy is going to have to stay. All right, downstairs I just have 9x cubed. All right, so then 6 times 3 is going to give us 18 up top. And then the square root, I can break these apart, so square root of x squared is just x, and then this square root of x to the first has to stay underneath there. I know it looks odd, but this one's got to stay. I can actually take the square root of this x squared, which cancels the squared and square roots out. So we just have x, okay, and the 18 came from the 6 times 3. And then downstairs I have 9x cubed. Well, guess what? We're not even done yet, because look, I have 18 and I have 9 here. Those can both be reduced. They're both divisible by 9. So 9 divided by 9 is 1. 18 divided by 9 is 2, so I can put this as 2 over 1. Also, I can actually combine these x's here because they're both outside of the square root. This one's got to stay, but this one I can. So here I have x to the first divided by x to the third power. And when we do that, we subtract exponents. So 1 minus 3 is negative 2, indicating to us that that x squared is going on the bottom. And whoops, I forgot my 2 up top. And what is left else? Well, these are gone now. And I have square root of x. Okay. Can I simplify these here? No, I can't actually do that because this one's under a radical and this one is not. Okay, so we have to leave this as such. There's no more numbers left to work with. There's no more variables left to work with. So this is our simplified answer. Last example. This one looks a little bit different than the first 3. So this one, though, is where you actually have to use your conjugate. Okay, so you're going to multiply just like we've been doing by the same thing on top and bottom, except we're not going to write this exact thing over. We're going to do this exact thing, except we're going to say, hey, instead of changing this or keeping this a positive, we have to change that to a negative. Okay, so we're multiplying by 1 minus the square root of 5 on top and bottom. Now I'm going to, since these are 2 things I need to be multiplying, I'm going to put parentheses on everything that has 2 things because I need to make sure I multiply right. So here, this just distributes in. So we have 2 times 1, which is 2. 2 times a negative square root of 5 is negative 2 square roots of 5. Okay. Can't actually bring the 2 in. Downstairs, we have to FOIL. So firsts, 1 times 1 is 1. Outers, 1 times the negative square root of 5 is a negative square root of 5. Inners, positive square root of 5 times 1 is a positive square root of 5. And finally, lasts, we have positive square root of 5 times negative square root of 5 is going to give us a negative square root of 5 times 5, which is 25. Okay. But we are not done here. We can keep simplifying. Top's got to stay. I know you want to subtract those 2, but you can't. This one has a square root of 5. So you can kind of think of this as they're not like terms. So you cannot actually combine these because this one's got a square root of 5 as its tail. Okay. Down here, what is like terms? Well, I have a square root of 5 here and a square root of 5 here. These, though, I have a minus 1 square root of 5 plus 1 square root of 5. Those are actually going to cancel each other out. And they should. We're trying to get rid of radicals here on the bottom. So those should go. I still have this 1 out front, so 1. And I still have this minus. Now, minus the square root of 25. Actually, take the square root of this. Square root of 25 is 5. Oh, phew, I thought we were going to end up with radicals in the bottom, but we won't. We're getting rid of it. And then keep simplifying. We have 2 minus 2, square root of 5, all over. 1 minus 5 is negative 4. Now I want you to notice here, these 3 numbers are very important. The 5 doesn't matter one bit. If I have 3 whole numbers out here and they're all divisible by the same thing, I can divide them all by that thing. Here we're all divisible by 2, so I'm going to do just that. So that's a 1, and that's going to be a 2. A negative and a negative here, of course. So then I have 1 minus 1 square root of 5 all over negative 2. And that's as far as I can take this one. So that's it. This is tough stuff, so be ready to practice it tomorrow.